When we use a website like Amazon.com or when we use a website like Facebook.com, clearly when you load a page and you click on another link, it still remembers you. It still knows who you are. And so the way that people have overcome this statelessness of HTTP, because this does in fact exist, is to use this concept of cookies that we had mentioned briefly a couple of weeks ago, but we're going to talk a little bit more about today. And so a cookie is basically just a small piece of information that a server will send to our computer in the HTTP headers, and more specifically in the response headers from an HTTP server, and will tell our computer to save this little piece of information for some future point. And the next time that my computer goes to that same website, it will then send this cookie information over. So I could then get a cookie, for example, from a remote server that looks something like this. Maybe it's going to be username and then a colon or a semicolon, and then maybe some long string of random words and letters, or just letters and numbers that look something like this: 7C64322, something that looks like this. So this is just one of many types of cookies that we can get. Basically, a cookie, it really can be anything that can be represented in text. Anything that can be represented in text, a server can actually tell our computer to write and store in memory, and then that same information will be sent back to the server. So this goes back to this question that we had earlier on when we were saying, well, is there a chance that when I type in a password to a website and it sends that password, is there the possibility that this password could actually be saved in some unencrypted form on my computer? And the answer, we said, was relatively complicated, but it is possible, and it is in fact possible with cookies. There's nothing stopping a server from sending a cookie that it doesn't look like this with some random collection of numbers and letters and my username, but is in fact my username, and then after like a semicolon, the password that I had actually used. Meaning that this password that I use, that is now vital to log into this to this website, is now stored unencrypted on my hard drive. And many of us, I certainly know that I don't go through all of the cookies on my computer. We may not even know that this password is then saved. Now, this is obviously a very bad thing. And if there are websites that are doing this, they're doing security wrong. Most of the time, especially the bigger, more secure websites that have been around for a while, like Amazon and Facebook, they know not to do this. But some of the smaller sites, they may be less experienced. They may not know not to do this, and so this is, in fact, a possibility. So like we said before, don't use the same password for all of the websites, because it's possible that that password is actually stored unencrypted on your computer without you even knowing. Now, coming back to this point, though, we have a cookie, and the cookie, again, is just some information that is written on our computer that a server has requested. So a server has said, I want you to remember this information until the next time you visit this website. And that's all your computer is doing, is it's just blindly saving this information somewhere on its hard drive, and the next time you visit that same website, it then sends this cookie information to the server again. And so in this way, it can then be able to say, okay, well, looking at this random number with this username, I can then remember, oh yeah, I sent that username, this random number, therefore this person is still logged in, and that's basically, in essence, how this actually works. How your session is preserved. How when you go to Amazon.com or Facebook.com and you click on one web page and you go from one page to the next, even though HTTP is stateless, how these web servers still know who you are, is using a cookie in this manner. Now, of course, they could use something like this, but again, this is bad, and generally, we're not going to see this very much, but the possibility does exist, so just be wary of that fact. Now, most of the time, though, like I said, that doesn't happen. Now, if, let's say, just as an example, this actually was a real cookie that I had written, and this cookie represents my session ID. It's actually a session identifier that identifies me to a server like Amazon or Facebook, and you go in and you modify your own cookie. You actually change your cookie that would say your own username and your own random number that was assigned to you by the server. You actually change that to represent mine, and you load up the web page. What do you think is going to happen? If you were to, in essence, use my cookie instead of your own cookie, and this cookie is meant to identify me to this web server, to this website, what might happen? Yep? Right, so you're going to hijack that session. So what this means is that if this was a real cookie, if this was actually my username, if this was actually the sequence of random numbers and letters that represented my session with that server, and you start using this same information, what this means is that the server is then going to be able to, the server will just think that it is then me on your computer. There's nothing stopping it because there's no real way for the server to identify. Again, because this HTTP is a stateless connection. Once the connection has been formed and then the data requested, then that connection is killed, it's quit. So that there's no way for the server to know that the next person, that the next request coming in is you, or if it's somebody else. It has to rely on some information provided on the computer to be able to identify itself as being this same user.